Okay, in this video, we are going to be going over power law, but in this case, we're going to level up, level up, level up, level up, level up. Okay, I couldn't resist. Okay, anyway, so today, again, we are doing the power law, but we're taking it to the next level. So let's start off with number one. Okay, number one, we have 5 to the 4th power, raised to the 2nd power. So as you can see, we have a power to a power, and then that's going to be divided by 5 to the 5th. Okay, so before we dive into the power law and using it, I'm going to show you how you can do it also in expanded form as well. Okay, so if this is your base, okay, again, 5 to the 4th power is now your base because that is being raised to the 2nd power. So you're going to write out 5 to the 4th twice, again, because you have the exponent of 2. And then that is divided by, remember, a fraction bar means divided by 5 to the 5th. Okay, now that you are here, we can write out 5 to the 4th. I'll use a different color. 5 to the 4th, 4 times. 5, 2, 3, 4, and then a second set. 1, 2, 3, 4, and then it is divided by 5 to the 5th on the bottom, which had 5 fives. 1, 2, 3, 4, 5. Okay, and then from here, you're just going to cancel. 1, 2, 3, 4, 5, and you are left with 5 to the 3rd power. Okay, another way that we could have done number one is realizing that, and remembering that the power law, you multiply your exponents. Okay, so we could have taken 4 times 2 and gotten 5 to the 8th power divided by 5 to the 5th power. From here, you could expand them if you wanted to, or we could have used our quotient law and subtracted 8 minus 5 because we are dividing. Whenever we divide exponents, we subtract them. 8 minus 5, and 8 minus 5 is 3, so it would be 5 to the 3rd power. Okay, so again, there are multiple ways that you can solve the problems today. Please choose the one that works best for you. Okay, number 2. We have 3 to the 3rd power raised to the 2nd over 3 to the 6th power, 3rd power raised to the 6th power. So again, one option is going to be to expand them. So this set, I'm going to write 3 to the 3rd power out twice because of this exponent. Okay, and then on the bottom, I'm going to write out this 3 to the 3rd power 6 times. 1, 2, 3, 4, 5, 6. Okay. Multiple ways we can solve this from here. Okay, we can continue to expand them all out. That is definitely one thing that we can do. Okay, so on the top, I know that I have 3 3s. 1, 2, 3, and another set. Okay, and then on the bottom, it's going to be a lot. I know I have a set of 3 3s, another set of 3 3s, a third set of 3 3s, a fourth set of 3 3s, fifth set, and a sixth set. Okay, that was a lot. Now, something else that I noticed is that if I have a set of 3 3s, obviously those are all going to cancel. This set of 3 3s is going to cancel. So if you didn't want to expand it out, we could have canceled out the set of 3 3s from here and then counted up the exponents that I have left. So remember, whenever we multiply exponents, we can also add them. So I could have added 3 plus 3 is 6, 9, and then 12. So that would be 3 to the 12th power. Okay, and let's count them up just to make sure we got the right answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 1 over 3 to the 12th power. Remembering that they're going on the bottom because that's where they landed. Okay? Example number 3. Oops, I switched to a blue marker. We have 5 to the 3rd power times 5 to the 2nd power raised to the 3rd power. And then we're going to divide that by 5 to the 2nd power times 5 to the 4th divided by 5 to the 2nd. Okay, by this time, I'm going to stop expanding them because we're going to start getting used to our exponent laws now, okay? The first one I can leave alone is 5 to the 3rd power because there's no power to a power here. So 5 to the 3rd power is going to stay. The next one, however, I have 5 to the 2nd raised to the 3rd. So I need to change that to 5 to the 6th because 2 times 3 is 6. Okay. On the bottom, I'm going to leave this 5 to the 2nd power because there's no power to a power. And then I'm going to multiply 4 times 2 because that is a power to a power. And that becomes 5 to the 8th. Okay, here you can expand it if you really, really want to. Again, I have no problem with that at all. However, we can also start using our exponent laws too. So exponent laws, whenever we're multiplying, because they're a multiplication or because they're side by side, we're going to multiply across the top. We add our exponents. So that would be 6 plus 3, and that is 5 to the 9th power. Over on the bottom, again, we're multiplying straight across. We're not dividing yet. We have 2 plus 8, and that is 10. That's 5 to the 10th power. And then again, we can expand them out if you would like to. Not a problem here. However, I'm going to subtract my exponents because it's the quotient law I'm dividing. This fraction bar here means to divide. And 9 minus 10 is 1, and that 5 is left on the bottom. So it's 1 over 5 to the 1st power, or just 1/5. Okay, hopefully we're feeling a little bit more comfortable about some exponent laws. We're going to keep it moving. Before we throw in a negative, we're not there yet though. Almost. Okay, one more example with the positive exponents. We have 4 to the 4th power raised to the 2nd divided by 4 to the 2nd power times 4 to the 7th. Okay, so not too bad. I see that there's a power to a power. So I'm going to multiply 2 times 4, and that's going to give me 4 to the 8th power. Okay, then I'm going to be dividing. I'm going to multiply straight across here. When we multiply exponents, we add them. And 2 plus 7 is 9. So 4 to the 9th power. Okay, here I am now dividing my exponents. And I know it's dividing because I see this fraction bar here. And whenever we divide, we subtract. 8 minus 9 is 1. And the 1/4 is left on the bottom because, again, if I'm looking, 9 is the bigger number. So I know that the 4 is left down there. And we can look at that as 4 to the 1st power, or 1 over 4. Okay, here's where your negative exponents come into play. Okay, so bear with me as we introduce you or reintroduce you to negative exponents, but now using the power law. Okay, so we have 7 to the 3rd power, and that is raised to the negative 2nd power, right? Divided by 7 to the 3rd power. Okay, power to a power, same concept. We're going to take 3 times a negative 2. So 3 times negative 2 is negative 6. So 7 to the negative 6th power. Divided by 7 to the 3rd power. Oh no, Miss Sams, there's a negative exponent. Don't worry. The negative exponent, remember, we look at that word as the word opposite. So this is the opposite of multiplying because it's on top already. multiplying by 7 6 times. Okay, so multiplying by 7 6 times simply means that you just divide by 7 6 times. So I'm going to put 6 sevens down here. 3, 4, 5, 6. And then I'm going to go ahead and expand out my 7 to the third power. Okay, now you could have wrote this as 7 to the 6th power. I have no problem with that. I just wanted to show the first example with expanding. And we have nothing on top, so we're going to put a 1. Count up how many 7s you have across the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 1 over 7 to the 9th power. Okay, I need to flip my page over because I'm running out of room. We are going to try to go to example 8 today. So on the back, I am continuing my examples. Let me get it in focus here for you. Okay. And we are on number 6. Okay, negative signs are going to finish out our examples today. So if you're stuck on negatives, please stay on the video and continue to watch. We have 3 to the negative 4th power divided by 3 to the negative 2nd raised to the negative 4th power. Okay, 3 to the negative 4th, I'm going to leave alone just for a second. There's no power to a power. I want to take care of that law first. So whenever it's power to a power, please remember that we multiply. And be very careful. It's a negative times a negative. So with Integer Man, if you had me for 7th grade last year, I introduced you to Integer Man, and he helped you out with multiplying and dividing negatives. So if it's negative times a negative, we're going to cover up his eyeball. And we are left with a positive sign. Let me try to move my markers out of the way. Okay, cover up the negatives. Negative times a negative, we're left with a positive. So 3 to the 8th power is positive. Okay, so with that being said, it's got to go up to the top. So we have 3 to the 8th power up here. And 3 to the negative 4th power. Just kidding. We're dividing by a positive 3 to the 8th power. I'm so sorry. I was thinking opposites. I was thinking of this guy. But we're already in number 6, so I'm not going to redo the video. And then this word means opposite. So we're going to do the opposite of multiplying by 3 to the 4th power. And let me just rewrite this so it's neater. Okay. So we have 3 to the negative 4th divided by 3 to the 8th power. Okay, that guy is going to stay because we're dividing by a positive number. That is okay. You can divide by positive exponent. I don't know what I was thinking. And then on the top, we're going to think of that negative sign as the word opposite. So we're going to do the opposite of multiplying by 3 to the 4th power, and that would be dividing by 3 to the 4th power. Now we have nothing left on top, so the 1 is going to go there. And now we're multiplying straight across. And so 8 plus 4 is 12, so it's 1 over 3, to the 12th power. Okay, let's take a look at number 7, or example number 7. Okay. We have 3 to the negative 2nd power raised to the 3rd power all over 3 to the negative 2nd. Okay, let's take care of the power law first. So I'm going to leave the negative exponent alone on the bottom just for a moment. Power laws are power to a power. So that's 3 to the negative 6th power, because negative 2 times 3 is negative 6. Okay, now this is when I was really thinking of with number 6. Okay. My brain is working, I promise. Okay, we're going to think of the negative sign as the word opposite. So this means that usually if it's already on top, I would be multiplying by 3 6 times. Not the case, because of the negative sign, I'm going to be dividing by 3 6 times. So 3 to the 6th power goes on the bottom. Okay, now because 3 to the negative 2nd power is on the bottom, remember our fraction bar means divide. So we're currently dividing by 3 to the 2nd power, but this negative sign means the word opposite. So we need to multiply by 3 to the 2nd power. Okay, now we can expand these out, and I think I'm going to just because we're going to end up having a negative exponent here, and I want you guys to see that. So 3 to the second power on top, and then 6 3s on the bottom. 4, 5, 6, and then from here we're going to cancel, and I have 4 3s left on the bottom, so my answer is 1 over 3 to the 4th power. Okay, number 8, last one. And this one is a bonus one. Okay, let me just go ahead and warn you. It is going to get a little complicated. So we have 3 to the 3rd power raised to the 2nd times 4 to the 2nd power raised to the 5th over 4 to the 2nd power to the 4th power over 3 to the 3rd power to the 3rd power. Okay, so if you really, really want to, we can expand all of these out, but I'm going to use the power laws. Okay, so power laws, 3 times 2 is 6. So I have 3 to the 6th power. Power laws, 2 times 5, and again, it's power to a power to a power, so I'm multiplying. 2 times 5 is 10, so that's 4 to the 10th power. Okay, divided by, I'm going to line up my like terms, so I'm going to move the 4 underneath the 4. Again, multiplication, you can flip-flop. So with that being said, 2 times 4, because it was power to a power, is 8. So 4 to the 8th power gets written on the bottom. And then we have 3 times 3, which is 9, and that would be 3 to the 9th power. Okay? From here, you are more than welcome to expand out your exponents. No problem with that. Or you can use your division or your quotient law. So here we have 6 minus 9, and that's 3. And the 9 was bigger, so my 3's are going to be left on the bottom. So that would be 3 to the 3rd power. Okay? And then the other one, you have 10 minus 8, and that is 2. The bigger exponent was on top. So 10 to the 2nd power goes on, 4 to the 2nd power goes on top. Okay? Now there was one more because this particular one asks for the value. Okay, so I am going to expand from here. Okay, 4 times 4 is 16. 3 times 3 is 9 times 3 is 27. So your final answer for the bonus example is 16 over 27. Okay, feel free to watch, pause, replay this video as many times as you need. If you are watching this video during the 2020-2021 school year while we're virtual learning, please make sure that you are using page 18 to do and work out your independent practice from Google Classroom. And again, today's notes was taken on page 17, titled Power Law Level Up. Best of luck today.